Thank you, Jamie. Thank you, Miriam and Emily and Saber for inviting me here to talk about what I've been doing the last year or so. Can you all see my share screen just fine? All right, perfect. I'm here to talk about learning ecologies and generative AI. But before I talk about my research, I think it's necessary to begin by briefly framing the discussion of Gen AI in higher education, because undoubtedly this is paradigm shifting technology, much like the internet and Google and smartphones have been in the past. And it's really hit our careers in particular like a freight train. It was kind of weird. I had to do the math, but ChatGPT dropped publicly, which is really when this hit the public sphere, less than 2.5 years ago. So I want to address how we feel about it, how we might use it as educators, how we might study it as researchers to really frame this discussion. The QR code that you see up here is to a share folder that has these slides, plus a few other resources that I'll talk about in my talk. If we can go ahead and share that link also in the chat. So how do we feel about the age of AI? Recently, the American Association of Colleges and Universities had a conference at the end of January, just a couple months ago, and had over 300 higher ed administrators, provosts, chancellors, and they asked them a number of questions about AI. Now, the overall data sheet is in that share folder, and the whole thing is a fascinating read. But I really wanted to point out the results for this one question, question 23. To what extent do you believe generative AI tools may impact students in the future? And all of these responses have a very strong kind of positive response of a lot or some. The top four being very positive things: enhance and customize learning, improve research skills, increase creativity, increase ability to write clearly and persuasively. But then at the same time, they're also agreeing with developing an over-reliance on generative AI tools, increasing concerns about academic integrity, decreasing attention spans, and widening digital inequities. And when I hear this, I think about all the conversations that I've had with others, what I've read, talking to students, and this really seems to mirror that feeling. I was trying to encapsulate it, what that really means, and I think there's this duality of technological advancement. And I just read, and I'll post in my references some links to some great articles talking about this by Tressie McMillan Cottom. She recently did an op-ed on this in New York Times, and Bill Gates on his blog website. But the idea is that the promise and peril of AI lies in teaching and learning. It's seductive to imagine what an expert might accomplish with it, but it's a siren's call to the novice. And the thing that's really scary is that the experts do not yet exist, right? Like, I am not an expert in how to apply generative AI in a learning environment because I don't think that person exists yet. This is 2.5 years old, and the way the technology was a year ago is different than it was a few months ago, is different than it'll be a few weeks from now. So we're really in this phase of uncertainty. So what are some primary questions for AI in DBER? Like, what should we do about it? And so framing this in a couple of questions. One, what are Gen AI's most appropriate use cases? And I think the bar for this should be, does it actually improve teaching and learning because it's something that can specifically be done by generative AI that we can't, such as answering emails and questions at 2 a.m. before a test? Or does it merely make a task easier to accomplish? And secondly, if we identify those use cases, well, then how do we use it well? How do we leverage AI correctly to achieve our goals, like the learning of our students? And I think inherent in this question is, well, how do we as DBER researchers, how do we do this? What research frameworks are most appropriate to study Gen AI as an educational tool? So primary use cases. If we think about it, I broadly section this off into teaching tools and learning tools. Now, if we focus on teaching tools, one is grading and summative feedback. And this is an entire hornet's nest of issues when it comes to privacy and accuracy and quality control. You're also often doing these things in bulk where you might need to grade 300 things at once. And so, because of those legal and ethical and technological barriers, there are a lot of amazing people working on it. I myself, it's one of my primary projects that I'll be working on over the summer. And a lot of people are working on it. However, I highly recommend that if you're trying to apply AI in your classroom at the beginning, this is not the place to start. A great place to start is to use it to just make your lives a little bit easier, creating curricula, assessments for general writing. Now, this I feel is kind of dealer's choice, personal preference. Is this something that you want to use in your life that affects you directly in your ability to succeed in the classroom? Where I want to focus today and what my research has been focused on is what about learning tools and specifically integrating chatbots into learning activities, what Sierra was just talking about, really. I want to focus on that and talk about how timely this is. Um, uh, I just made this slide yesterday because I read, well, April 2nd, Claude is introducing Claude for Education, which similar to what Pearson has is a Socratic chatbot, which is similar to the chatbot that open source one that I've created that I'll show you. So that was just a couple days ago, and then published in preprint on March 31st, large language models passed the Turing test. And for this, two researchers in the Cog Sci department at UCSD demonstrated that the newer ChatGPT model, or LLM model 4.5, passed the Turing test about 75% of the time, where previous models like 4.0 maybe passed it about 20 to 30% of the time. So this huge jump in just us thinking that who we're interacting with is a human. So what are the different types of chatbots? What levels are they if we want to incorporate them in the classroom? Well, at the bottom of the pyramid, kind of the easiest way where most of us start, is by just sending students to a general open chatbot like ChatGPT or Claude or Gemini, giving them a set of prompts or instructions, and then having them do some sort of reflection or feedback based on that. Custom chatbots, now it's something that you control. You control the system instructions to it. You may also then bear that cost. And then custom chatbots with tools, which I'll talk about in a sec. But I want to focus on kind of the pros and cons of each of these. At the bottom with ChatGPT and Claude, this is low effort, low tech buy-in, right? As long as somebody can go to ChatGPT and you have a prompt and an activity, this is something you can do. You are beholden to default chatbot behavior. So it's not trained to be Socratic. It's trained to please you and do an info dump. And often a lot of the parameters that dictate it may be a bit more creative than you'd want it to be, especially in a STEM setting. And students pay for this. So there's a big inequity. $20 a month is expensive to pay for a lot of these more advanced models. With custom chatbots, it becomes a lot cheaper. So the app I'll show you, students interact with it through an app that I create, which then communicates with the same LLM models, large language models, but through what we call an API call, meaning there's code that communicates the conversation back and forth with the model. That's a lot cheaper than $20 a month, and this is something the institution would pay. Now, I just did an analysis of my winter class, and to give you a feel of what that cost is like, this was 10 weeks where we used it for multiple activities. There was 12,500 separate chat messages for well over 100 million tokens, which is kind of the currency of words in the LLM world. So heavy usage, and the entire thing cost about $177. It would have been about $20 if I was using a cheaper model, but I wanted to use a more advanced model for this. Now, for 300 students, comparing that to $20 per student, that is a huge gap, and then also something that we could fold into potentially instructional budgets, pay for it the same way that hopefully we pay for paper printing of final exams. Now, the instructor guides the chatbot behavior, so it can make it Socratic or give it context of like, what's the class all about? But this does require some effort, which I'll show a little bit later. And then finally, at the top, we have custom chatbots with tools. This means that it's not just an LLM, but maybe you're providing it with a bunch of material like PDFs. You're asking it to run code, to do quantitative analyses, things that aren't just kind of text. This is either you're paying a company quite a bit of money for an enterprise account to do this, or there's a lot of high effort put into it, and it's usually pretty customized for that class. It's not as easy to template that and copy it between individuals and instructors. Whereas a basic chatbot, it's a lot easier to do that. So I have two different chatbot tools. Today I'll be talking about schema study. And so we'll see kind of what that is in a second. But I also have a basic chatbot template, which is really you customize instructions. You have a web page that has a little chatbot. You can embed it into any Canvas activity. Some of you in the audience I've worked with to get these set up in your classes. It's cheap, and within an hour or so, I can get it up and running. And so both of these are kind of available and out there, open source and free, other than paying the API costs, which if you're not teaching at volume to 300 students is probably going to cost you a couple of bucks. How do we then research this, right? If we want to apply this in a way that is achieving our learning goals, then I don't know if typical experimental approaches are appropriate. And what I think works best in this scenario with generative AI is design-based research, or DBR. And DBR comes from more of the engineering space, in which you have a prototype, some tool to accomplish a goal, and then you go through this iterative cycle in order to improve it. There's the design element. What are my goals? I'm going to design and prototype this thing. I then test it in the real world, evaluate it, reflect on what needs to be changed, and iterate. And so DBR is right in between in this kind of continuum of how controlled the learning environment is, with a highly controlled experimental approach in which you might have different treatment groups where you're really trying to eliminate any variables other than the ones that you're hypothesis testing, and action research. Action research being an instructor in the classroom is trying things and just seeing if they work in that exact context with really not controlling much of anything. DBR sits right in the middle. And I think it's important because the way it sits in the middle is that it really focuses on the importance of a learning ecology. That the intervention you have, in this case, generative AI, does not exist in a vacuum. That how students interact with it and learn from it is going to be a product of how you talk about it. What other assessments and training and resources in the classroom are going to be involved with it? What's the subject that you're learning? If it's physiology or science process skills or statistics, that is also going to have a huge effect on how to appropriately use it. So the four tenets of DBR is kind of what we're used to in biology education research, is that it's grounded in theories of learning and it aims to improve student learning. So we do want to have generalizable kind of information that comes from this research, but it's more so going to be in these design principles and strategies for if you want to implement this in your own learning ecology, what are some tips and tricks and ways that we've seen that we can actually gauge and improve learning. And extended iterative experiments. So this is meant to be a thing that even if you publish a paper on a project in DBR, you're not stopping with it. You're still iterating and improving over and over and over again. What introduced me to this, I've linked the paper in there, is a absolutely canonical paper that I love. And this is Emily Scott, Mary Pat Wenderoth, and Jennifer Doherty a few years ago. Really wrote the paper that, at least for me, introduces this into biology education research. The link's down below, the figures from their paper. I highly recommend you. It's a good read for everyone. Now, why is it right for Gen AI education research specifically? One is that the tech's evolving too fast. That if you were to set up a controlled experiment, that by the time it gets published, the models that you're testing on are no longer really used anymore. So you can, look in the preprint servers and say, okay, we just saw a paper that came out and it's about a ChatGPT model that is maybe 2 generations ago. And so the technology is improving too fast for the typical experimental approach to keep up. Also, the interaction among students, instructors, and the LLM is highly dependent on the whole learning ecology. And I think for 2 reasons. One, LLMs are probabilistic black boxes. So if I do a controlled experiment in which I want to see if a chatbot works, and my instructions to the chatbot are be a helpful assistant, and then I just change those instructions, well, my outcomes are going to be different from their outcomes. And so you do any sort of tweaking of that context, of that learning ecology, and things are generally going to be quite a bit different. And students require significant support to use effectively. Just as we feel stressed out thinking about AI, students do the same. And there is a huge gap between students that use it a ton and understand it really well, and students that are intimidated by it or have relatively little experience with it. And so there needs to be a really robust learning ecology with training and low stakes assessments to support it. And the nice thing about DBR is it accommodates these iterative changes that you can use in real time. We'll see later that with Gen AI, the biggest thing you can ever do is test, test, test. Is that if you have a prompt and you're getting it ready for an assessment, pretend to be a student and see if it works. Slight changes can vastly improve your outcomes. And if you're not restricted by those changes, and DBR really wants you to make those changes and test them, then that can be highly effective. So I want to show you really quick a demo of this app. If we can put the app and password in the chat. This isn't really meant to be a walk along. I'm going to move through this kind of fast because I don't have an enormous amount of time, but this is going to be left available for you to play with. And if you're interested in copying and customizing your own version of this, then please let me know. It's that top link, and the username and password is HAL9000. And so I'll go ahead and kind of show you a little bit of what this app is. So first, it is just a normal chatbot, right? There's a window that shows your chat history, and you can just type stuff down here. What I have here in this instructor evaluation version that students don't see is that these are the specific system instructions that over a long period of time I've tested and chose to really kind of give me the evidence-based teaching and Socratic tutoring that I'm looking for. So free to read through this and what information is being given to the chatbot. Because basically, this whole prompt is given to the LLM every time a student has a conversation with it. So it is that those beginning instructions that the system hears about before the student talks to the system. Now, what are they talking to the system about? And this is where schema study is a little bit different from your typical chatbot, is you can add on your own content, but you can do it in a way that's, I think, as straightforward as possible technologically, and that's in the form of a spreadsheet, a CSV file with 2 columns, terms and context. And so you choose whatever terms you want your students to think about or talk about. There's no real limitation in what they are. I've put up some things for ecology and evolution, which is my background. You can put in, Shannon Diversity Index, calculating a t-test in Excel. You can talk about things that aren't biological content, like RU experiences, or I do coding, so making a figure in R, or talking about data science, or even things that are kind of logistics, like what are the learning objectives for week 1. And in content, in context, this is everything that you want the LLM to know that isn't part of its base model. This is really helpful. You can add in your own course definition, for example, natural selection. You can talk about specific characteristics that you want them to know. I have related terms mentioned in class. And one that I particularly like is, well, who or which scientist do you talk about in relation to this? So instead of like if you were to ask a regular model who talks about this, it's mostly going to be just Charles Darwin all day long. But I want them to talk about who I talk about. In this case, Hopi Hoekstra, Rosemary and Peter Grant, Rosemary Gillespie, Paul Turner, who does phage therapy. You can put that in here. You can also say, well, associated lectures. You don't have to put anything at all. It's really whatever you want. So I'm going to run through a couple quick examples of this. And so for the first one, if I choose natural, if I choose natural selection, okay, what is one thing you want to know about it? What schema study is really trying to do is say, hey, tell me what you know about this thing. Tell me what you don't know, and we'll kind of work Socratically through there to build that schema or that concept map. So the idea behind this is based in cognitive schema theory. And let's just put in for natural selection. I don't know, what is it? Okay, survival of the fittest. Yeah, then it clarifies that's not really the most accurate way of putting it, and then it follows up with a Socratic question, something like that. I can even start to get, or you can prompt them to get creative with it. So you can say, well, I want to do a game. I want to play a game, two truths and a lie. Who studies microbes in evolution? And so, okay, I know in this case, Charles Darwin knows for primarily studies mission. Well, okay, that's a pretty specific one. I think Alfred Wallace, because he did a lot of butterfly work. But if I wanted to do this separately, like who do we talk about in class? I can then go through and it will pull specifically from that. If I want to say for sexual selection and I go up and choose, I can just ask like, when did we talk about this? And these are all the things that were listed in that file. And then if we want to get to kind of a higher level, and that's the goal, is that eventually they can kind of start having a creative conversation with the chatbot. Is I have all of these for the students level up instructions. And this one is kind of playing 6 degrees of separation. But the idea is if you choose a topic, then can the chatbot randomly choose something else from the list? And then you have to come up with a hypothetical scenario that connects those two ideas at a higher level, and then it'll critique your scenario. So it gives a setup example of bats and nitrogen, and so it shows to connect sexual selection with mutation. And so now I would need to come up with a scenario in which 6 degrees of separation, how are these two things connected? And there's really no end to how you could go about or get a student to engage in quizzing this material. It's really meant to be open-ended. What's the learning ecology for this? Well, as mentioned earlier in the intro, I'm currently using this in data analysis and design for biologists. This is a required part of the Intro Bio series for all biology majors. And it's a practical, this is a course description off the website, a practical introduction to information literacy, experimental design, hypothesis testing, and data analysis for biologists. Students will be introduced to coding, data management, quantitative statistical analyses using the R programming language. This was really an offshoot of shout out to Stanley Lowe when he was hired at UCSD. He was really brought in to start our introductory biology lab in part, which is amazing, a class I've been teaching for a really long time, where we wanted to start to have classes that were explicitly focused on helping students learn and practice science process skills. And this is really an offshoot of that, where we wanted more space to focus on things like experimental design, statistics, and tool usage like coding and data science. So how then do I incorporate this into the class and not just throw schema study at them? Well, first, there is a part of this incorporated directly into the academic integrity policy in my syllabus, and I both talk about it in class. What is cheating associated with ChatGPT, and how do I deal with that? Live demo. So both in lecture, I'll talk about it and show them how they can explore course concepts. In discussion section, which is really where we focus on coding education, we'll use this then as an aid for coding with R. And then where they get to practice with it the most in a structured way is with low value discussion board posts. So one is find interesting info with the chatbot and verify that info with a valid resource found online. We ask them to explore data sets and use that to generate code to make a visualization in R. This is particularly nice, and I'll show an example of this on the next slide, because students that have no command line experience get to use this as a tool so they can make a very professional coded figure after just 3 weeks after they, are first introduced to the command line, and really seems to give them a boost in their confidence in using those tools. Connecting two terms from the term list in a creative applied scenario, which I showed you. So another example in this class is maybe connect p-value with IRB review. And how are those things connected? And so maybe the bot and the student work together to say, well, okay, with p-value, well, we have a threshold p-value called alpha, and that alpha might be a little bit lower if we have some significant ethical risks to being wrong. And that would be something that would come up in IRB review. And then encouraged use for section assignments, final exam, their term project in this course in which we simulate and generate data for them to analyze based on a question of their creation. And so for all of this, we try and just promote as much practice as possible without leaning on it too much, but just giving them those opportunities. So an example of one of those discussion board prompts is in week 3, they use, and sorry, this is an old slide I haven't updated, they use schema study or ChatGPT to generate a data visualization. I asked them to look at a common data set like iris, and then make a figure. These are some of those student-generated figures. And then in week 5, we asked them to take another student's code from previous and then use that to update that code. I also have practice assignments for their coding assignments in which they need, I create errors in code and then ask them to use generative AI tools to help bug check and solve those errors. So evaluate, like, how did it work? Is this something that was effective? And apologies, this is data that I just analyzed because this is all from winter 2025. Final exam, spring break was last week. So this is stuff that I finished the analysis on pretty recently. But it was robust. This was the second time that I'd run the class. I had run it in a small class this past summer, and then this is the same app that I had run a seminar or workshop on at National SABER last year. And so I had 225 students. The class was larger, but these are the number of students that provided both complete pre and post course surveys. And so I had pre and post course survey data on attitudes toward AI, attitudes toward schema study, and their self-reported usage of the app itself. I could also pair this and join that table with student demographic and gradebook data. So one question is just, did you like it? Like, is this something that you would choose to use again? And interestingly enough, it seems that that answer was yes, for the most part, for another biology class. So using it in this context specific to the class, they were connecting this to more so of a biology technology rather than computer science or physics, which had a lower percentage right below it. And then even lower, 44% for a non-STEM course, where a lot of the focus of generative AI, like writing essays, usually is, that percentage was quite a bit lower. Found very surprising. And then I know this is a little bit hard to see, so the PDF is shareable, but I had a number of questions about attitudes. And what I did was then took paired data pre and post of what changes were there. And so we have here that change with zero, that red line in the middle, 95% confidence intervals. So it was a significant change if that confidence interval does not cross the zero. And to the right is increased agreement with that statement over the course of the quarter. And to the left is increased disagreement. And so I'll read off some of the ones that had the most significant changes. One is I can become over reliant on generative AI technologies. That mirrors exactly what we saw in the AACU data from that one of those first slides. I think AI technology such as ChatGPT is a great tool as it's available 24/7. I think AI technology such as ChatGPT can provide me with personalized and immediate feedback and suggestions for my assignments. It can provide me with unique insights and perspectives that I may not have thought of myself, like the creativity prompt from before. It will save me time. It will help me and prepare me for my career. It's going to be a part of my learning practice in the future. And one thing that felt really nice was that learning how to use it is easy for me. That's something where we saw a significant increase in that belief. And this is paired data, so this is comparing how that one student felt at the beginning to the end. I'm not lumping this stuff together. More qualitative, I asked for their comments in this, and I just analyzed this, so I haven't done any code booking or thematic analysis or anything. But just looking at it in general, some of the perceived strengths seem to be it was tailored to the specific curriculum, ensuring high relevance to course material. So a particular quote was, I believe it was helpful as it focused specifically on the course content. It promoted deeper understanding by guiding students through thought-provoking questions rather than giving direct answers. I like schema study more than other AI programs like ChatGPT because of the personalized feedback and questions that sparked critical thinking. I felt more like I was actually learning something than getting an answer spit back out at me. That one felt like super good. Effectively clarified key concepts and provided responsive code feedback. So when completing my final project, I found schema study beneficial in correcting simple errors in my code, and it helped me understand the meaning of specific code. Because in this class, we're not about memorizing equations, we're not about memorizing syntax. This is really about kind of intuitively understanding how do you speak to a computer, things like that. So it's really helpful with code annotations. Some perceived weaknesses, which kind of mirror some of those strengths. It provides less comprehensive and detailed responses than ChatGPT. To be honest, I mostly just use general ChatGPT instead of schema study because I kind of preferred it, but I think because I think it gave more comprehensive answers. The forced Socratic nature of the chatbot was frustrating, especially if I didn't know what questions to ask. I found it to be nice at times, but it's frustrating that it's trying to ask you questions in response to a question. And schema study was valuable overall, but sometimes I would try to ask it something, and I know the point is to get you to think, but I answered 15 of its questions once, and it still didn't help me with what I asked, which frustrated me. Totally feel you there. It's one of the hard parts with the Socratic chatbot. Primarily used when mandated, struggled to attract consistent self-motivated use. I never use schema study except for the discussion board, so I don't have an impression for this. So now to kind of get to usage data and how did that affect their opinion? So I did a logistic regression seeing if their usage, average length of a single session or self-reported days per week on average they used it, if that could predict accurately whether they would recommend schema study or not. And this was the recommended for a biology course, that 71% yes category. The results were that average length of a single session was not significant, but days used per week was significant by quite a bit. The odds ratio is 2.06, which effectively means that each additional day of use per week more than doubled the chance that a student would recommend schema study. And then you can kind of see this in this figure where I'm just showing in a bar chart days per week. And would you use schema study again? You can just see that increase, that shift over to more usage, more likely to want to use it. And I think this actually goes back to the qualitative assessment with it's a technology that takes practice. The more you use it, the better you get used to talking to a chatbot and feeling comfortable with that type of conversation. Did increased usage predict a higher course grade, right? Did it improve learning? And for this, at least with this data, the answer is not really. Linear model with all usage and preference data, the R squared value, like how much variation is this explaining, was next to nothing. And it wasn't significantly different from zero. There was, if there was anything in kind of the bigger linear model where I put a bunch of stuff into it, mean session length was the strongest predictor. And depending on how I set up the model, it was either significant or not. But it was actually a negative effect on the grade. So you can see in orange, those are students that's the trend line for would recommend the class. And the teal one is would not recommend, or not the class, but schema study. And they're both sloping downward. But when you look at the dots in here, it's not very clear. So there just isn't strong evidence either way as to whether it actually helps predict a higher course grade. So what does this all mean? How am I going to use that design-based research protocol of reflecting and iterate? Like, what am I going to do differently next time to hopefully improve student learning? One is I need to collect more robust and detailed data. I asked for self-reported usage. I need user analytics and accurate logging. Like, how much did they actually end up using it? And if I can then get even records of what the chat was, then I can even start to look at or assess the quality of those interactions. That is a technical hurdle, particularly when it comes to privacy and tech barriers of, where does this data reside, and logging in and having students individually be identified through the app, which they currently aren't. So there are some tech issues with getting that. And then also not comparing it to just course grade, but going in and looking at my pre-post course concept inventory data and seeing if that shows any effect on student learning. A/B testing of new functionality. So there are some things I want to do, and I really need to kind of A/B test them out there where some students get access to one versus the other, and I see what they prefer. One, I think, is just making everything simpler with a streamlined term list and a simpler UI. Practice deep, longer conversations with the Socratic tutor, right? I saw this matched pair in perceived strength and perceived weaknesses. I love that it's a Socratic tutor. I hate that it's a Socratic tutor. And I think the key to that is just more and more practice and instruction, particularly on the how do I prompt and communicate with a chatbot, which is a little bit different than talking to a person. And explicitly clarify the use cases of schema study. I don't think I really did this. I think I unfortunately compared it too much as a ChatGPT replacement, and it's really not meant to be. This tool is for learning and studying. It is not meant for getting an answer quickly with a huge info dump. And sometimes that's what a student wants. Like, let's say if they are trying to fix their code, right? They may not want to keep asking questions about it or answering questions about it. Well, how does this do? Oh, I hate it when I screw the animations up in order. But what are my recommended design principles? For this in general, like how do I think what I've learned can apply out there? Set clear guidelines on how students should and should not use AI and help them form realistic expectations. Design a user interface and learning activities that are intuitive and easy to navigate. It's already hard enough for them to use it and to incorporate it. It's new enough. Try to make it as easy and seamless as possible. Incorporate multiple low-stakes hands-on assessments to demonstrate where AI excels and where it falls short. So this is explicitly focusing on assignments in which they are evaluating its information for accuracy and credibility. So really data literacy and information literacy. Practicing metacognition and developing effective study habits. Engaging in extended dialogue. And gaining confidence through coding exercises. This has been absolutely game-changing as a tool and helping students feel good about their ability and identity as a potential developer and someone who can code. Regularly test and fine tune the system. Even small tweaks to instructions can lead to unexpected outcomes. That's a huge one on the instructor side. So yeah, that is it. If I have my lab website up here in QR code, if you're interested in collaborating or learning how to copy these or customizing your own copies, here's my email address. And then my last slide is just my references. So that's it. Thank you. And I invite any questions.
Thank you so much, Dr. Ruther. That was great. Lots to think about. I'm feeling a little overwhelmed, I'm not going to lie. I want to be able to do this, but it seems so complicated. I'll just remind everyone, if you'd like to ask a question, please put it in the Q&A. I'm hoping I'm looking at this correctly, but I don't see any questions in there yet, but I have some questions. Am I missing anyone's questions, though? You can just unmute yourself if you put one in there and I just can't see it because I don't know how to use tech. No? Okay, I've got some questions to start us off. Um, so I know because I actually went to a presentation about this exact thing, creating chat bots, TAs, and the information you had in there, all those terms and definitions, and that seems like that takes a long time to put in there. Are there already uh, curated collections or things that you can put in there, or are you putting in a textbook? And if so, are there copyright issues when you put a textbook into the chat bot?
Yeah, so definitely yes. Putting a textbook in is kind of that next level up of tech complexity. The tool name is called RAG, but that's when you start putting like PDFs and things like that in there. And yes, you definitely want. I know Mike Klimkowski has started to do a lot of this with some of the things that he's been working on, and often that means either you wrote the textbook or it's something that is by definition open source like OpenStax or something like that. In this case, all the information is just stuff that I've written in that CSV. Now, creating it does take work, but I can leverage and I have leveraged generative AI to do a lot of that time consuming work for me. So, for example, let's say I have a bunch of learning objectives for my class, and that's already written. If I'm comfortable, I can put those learning objectives into a generative AI and ask for it to come up with the term list. You can even have your class do this as like a, hey, for this week, as part of this assignment, list all the things that we learned this week. Like have your own students kind of curate this list for you. Once you have that list, then you can even put that list into back generative AI by giving it, say, my template that's on this website to give it formatting, um, and then just ask for it to create it. And then you, as the expert, don't have to write it all from scratch. You're really just going in and kind of editing and fixing things. So thinking about it as kind of a data supervisor, I'm letting the GPT do a lot of the legwork, and then I'm just fine tuning things. A file like this can be created a lot more quickly than it would have been able to create in the past.
Excellent. So I'm going to combine two of these questions. I know you have a platform, and I'll drop it back in the chat of one that people can use. But are there other platforms, and how do you just onboard faculty like me that are AI scared or coding shy, or what are some of the ways you can reduce the energy footprint of doing this?
Yeah. One is just play with it, right? This is kind of something that we tell our students when they're learning how to code, is that you're not going to break your machine by just running a line of code doing what we're doing. So, getting onto ChatGPT or Claude and just kind of seeing what happens. Now, I can send this out and share it and send everyone that was here a link. But I have an app that is publicly available where basically you can tweak the settings and tweak the system instructions and then just pretend to be a student. This is not schema study. You can have it be for anything. Have it be a chatbot that gives you sonnets speaking in pirate, right? Whatever you want. But you just change it, the system instructions, you pretend to be a student and you see what that looks like. And I think that's kind of one key is just play with it and see what it does. The other is honestly YouTube is pretty great for 5 minute, 10 minute short form content of how do I write a good prompt? How do I kind of practice with some of these things?